Hey, everybody, and welcome to another installment of CDK Live. Today's show is going to be the second in a four-part series where we walk through the CDK workshop. And so, first of all, for those that are new to the channel, definitely check us out at cdk.live. That's the URL, that's our YouTube channel. Check out all the content there. A lot of really great stuff focused on CDK, various projects around the CDK, and some really cool things that are happening in the community. Secondly, as I mentioned, this is the second part of the workshop. So in the YouTube channel, you should find the first part of the workshop where you can go and catch up. So if you're here live, stick around, and then when you want to go back to that content, please feel free to check that out. So I'm going to share my screen and we're going to just dive right into it. But for today, our focus is going to be deploying a serverless API using the CDK. We're going to do it using TypeScript, and it will use API Gateway, AWS Lambda, and we'll show how the CDK can bridge all of that together and do all of not all of, but a lot of the heavy lifting that normally, things that you have to think about, like IAM roles, connecting resources together. We're going to see how the CDK is super powerful in that regard. So let's get right into it. So now I'm going to ask, and it may be, I'm sure I have a really wide screen and I'm sharing both. I'm just wondering if this is not the best. So if folks are looking at this thinking this is it's too wide or too small, I may just actually go to sharing the individual screen, and then I'll just have to go back and forth. So please do let me know as we go through it. So, okay, last week we instantiated or initialized a new CDK project. We bootstrapped our AWS account as well as our AWS region, and we deployed a test application. So some test infrastructure as code. We deployed an SQS queue amongst a couple, and then we also subscribed to an SNS topic. Let's actually look at the code here so we can see what we did. So you can see we created a queue. We also created an SNS topic, and then with that topic, we added a subscription for that SQS queue. So again, back in the previous episode of this workshop, when we walked through this, we had showed how I believe it was something like 500 lines or 300 lines of CloudFormation was generated all through this just few lines of CDK code. So we deployed all of that. Now, the next thing is we're going to deploy that serverless API. So now we're going to go into a more real world type use case, and we're going to deploy this API here. So you can see we'll get an endpoint, which will hit an API gateway, which will then invoke that Lambda function on the back end. And then that Lambda function is going to respond with just a very basic response. So before we get started, though, and we didn't do this in the last workshop, or the last episode was clean everything up. So we're going to do that now. And what we'll do is we're going to just delete all these resources we created. So remember, one of the biggest benefits of infrastructure as code is that it manages state for you, and it manages the state of those resources that you've deployed through infrastructure as code. So I'm deleting code here, and what's going to happen? Yes, I'm assuming you answered, behind your computer screen there. But what's going to happen is that it will recognize that this code is no longer defined or desired state of that previous infrastructure as code has changed, and then it will delete those resources and then create the new resources that we define here. So let's actually, as we run through this, so we deleted that code, we're going to save it, and then we're going to run a CDK diff. Let's see, I'm going to do this, and I'm going to put this over here, and I'm going to put this over here. So am I in the right account? I wonder if I'm in a different account. And grep region. I think what I think I did this in US East 1. So US East 1, let's do a CDK diff again. And let's see if anything changes. I'm pretty sure I did it in US East 1. Yes. Okay. So what's happening is I'm running a CDK diff. It's going to do exactly what I just mentioned 2 minutes ago. It's going to recognize that we deleted all those resources from our code. So it, in turn, is going to delete those resources on our next deployment. So that was the CDK diff I just ran. And we can see that everything is going to get destroyed that we created. So let's just do this. Approval never. And we're going to let that delete. And while that happens, we're going to actually move on to defining and deploying our Lambda function. So to start, we'll want to create a directory. And actually, let's do this code workshop. All right. So we're going to create a directory, and we're going to call it Lambda. So another really cool thing about the CDK is you have the ability to bundle your application assets alongside your infrastructure as code. So when I say application assets, think a container image that contains your application code, or just your application code itself, whether that's bundled into a zip file for a Lambda, or you just have your code and you want the CDK to bundle it for you. So what we're going to do is create our code in this directory, and we'll go here. And oh, I see. So we'll do that in just a moment. But first, let's just create a hello.js. And yeah, I'm going to copy paste. So we'll do that. So what we have here is our Lambda handler. So if you ever have deployed a serverless function, you have your Lambda handler, which is that method that's going to get called on the invocation of that Lambda function. So we'll say keep it as the default here. Hello CDK, and you've hit this path. So the other thing about when you're working with Lambda functions is you get that event. So whatever resource instantiated or called this function, it's going to send a payload as the event. So if it's an SQS queue that triggered the function, you're going to get the messages in that queue based on like the batch size. In this case, it's an API gateway, so it's going to send us some details about the endpoint and the call that was made from that endpoint. So we'll stick with that as is. And again, this is just a very simple Lambda function, does nothing crazy here. So let's see if it wants us to change. So yeah, so by default, when you initialize your CDK repo, it will ignore the JavaScript files. That's because a part of the compilation process with TypeScript that will transpile into JavaScript. So it adds those to the get ignore. So we will actually change that down the road here. Okay. So what we're going to do is walk through deploying this function. We're going to go back to our CDK code. We're going to define a Lambda function, and we're going to then deploy it. Now, as you know, like we say in the workshop here, if you're walking through this on your own, it's best to type this code out and not just copy paste. So in this case, what we're going to do is we're going to deploy a Lambda function. So I'm not going to copy and paste that, but what we recommend is you go to the API reference here, our API reference documentation. So I know the first thing that I want to deploy here is a Lambda function. So I'm going to look for AWS Lambda. I can see the various constructs that are available to me. And we can click the overview here. It always has some good examples, things you can work with to get started. And it also walks through, especially with Lambda in this case, the various ways that you can deploy your code through Lambda. So what we'll do, and also it's really good to use these AI helpers. With the launch of Amazon Q as a kind of AI coding companion, I'm a big fan of these. You can see here in my IDE, I can ask questions. I want to deploy a Lambda function using the CDK and TypeScript. Please help. and then it will come back with a response, and I can then use that code to get started or to get to where I need to go. So regardless of if it's giving you the most perfect response, that's one thing, but it is a great way to get you started and to get you going with some code samples, examples to build off of. So, and then you can insert it into your code here, so you can see I can have it insert right there. All right, so I'm going to minimize this for now because it's kind of hard to see. So what we're going to start first is we're going to import our library, and I want to import the Lambda constructs. So again, I am using this Amazon Q, so it's giving me suggestions on the command line here, which makes my life a whole lot easier, or on the command line in my IDE. So it gave me that suggestion to import the library that way. So, all right, let's start by defining our Lambda function, defining. So we'll just name it hello, and then we're going to call this Lambda function. So we're going to say lambda.function, and then we're going to just define it as hello handler. Okay. And now we're going to pass in the properties that are required for our function to run, as well as any optional properties we may want to pass in for our function. So again, using the IDE, I have a lot of really nice native functionality, IntelliSense with VS Code that helps me figure out what are the required properties and what are optional. So we'll start with defining our runtime. So in this case, we're going to do lambda runtime.node.js, and we'll choose, so in this case, we chose 16, already behind. We should be choosing a newer version at this point. And then we're going to choose our code. So this is where I talked about bundling those assets. If you were to do this on your own, or if you were to deploy in other ways, not using the CDK here, you'd have to think about deploying that function code and then syncing that function code with your Lambda function. So you have to consider all of those things and multiple deployment processes, and then how do you merge those and track both of those together. So that's very challenging. But by bundling your application code with your infrastructure as code here, you have a single location where you store your artifacts, and you can track all those changes in one place. And anytime you make a change to your application code, that's going to get deployed via your CDK deployment. So we'll go with Lambda code, and then we're going to say from asset. So you can see the various options here. If I was using, I could use a Docker image or a container image that the CDK would then build that image, push it to ECR, and then sync that to my function. But in this case, we're just going to define from asset, and then we're going to say from the Lambda directory. So we're telling the CDK that when it builds this Lambda function, the Lambda directory, which is here, is where we have our code. So in this case, we just have straight JavaScript, but for more advanced use cases, you may want to bundle your code. If you might use npm or have some other build process that's required, you can always add that to your asset building code as well down the road. And then we will just define our Lambda handler. So remember, that handler is that entry point into your application. So you can see here, this is where we have our handler defined, and we have our hello.js and then our handler method here. Okay, so we've defined our Lambda function, and I don't like that this is node 16. I'm going to go node 18. Let's see if I break it. This is fun. This is when you do things live, you see what happens. So we have our Lambda function code defined here. We've chosen the path of where our code lives, and then the entry point to our code. So when that Lambda function is invoked, what is the response? What function is it going to run? And how is it going to do the needful there? Okay, so and then in the workshop, we do walk through working with constructs, the scope. And this is a good point, that anytime you call a construct. The constructors are always going to be the scope, the ID, which is going to be the identity of that construct. So think of the identity of this particular function that you're deploying, and then the properties, which are not always required. There are some constructs that don't require properties, but this is where you'd have either your required or your optional properties defined. All right, so let's save our code, and now we're going to run a CDK diff. And let's move this up here. Oh, let's see. Let's go to, let's see if I hard-coded things. I didn't. My account. So if I do AWS STS get, let's not do that there. Actually, I'm going to go to my AWS account. I don't know my account number. So we're going to log in really quick. Let's AWS log in here. So I'm on a separate screen really quick. Just going to get my account number, my IAC demo account. Let's do that. And then env grep CDK. So you can see, oh, I don't even have that defined. Okay, so let's do this. Let's pass in our environment. And then we'll choose account. And then usually you can choose that. You can use the environment variable, but in this case, I'm just going to pass that into my CDK application when I create my resources, so it knows which account to look for. I think actually, and it makes sense to me now, if I go back here and I run a CDK and I go env grep CDK, you can see, oh, I don't have that here. Let's see. Something's up with my credential chain, but it worked here. Okay, so now what it's going to do is run a change set. So let's go back here. It's going to run a change set. So we're running a CDK diff. It's going to look at what exists presently in the environment with my previous infrastructure as code desired state, and then look at any changes, and then tell me what's going to be deployed and what's changing. So you can see here, we're deploying our IAM role, and we're deploying a Lambda function. So it's creating a service role for that Lambda function, and it's attaching that service role to that Lambda function. So you noticed in my CDK code, I didn't create an IAM role anywhere. Just by default, it's going to create that role with least privilege and only the required connections that are needed. And then it's going to attach that role to my Lambda function for me. So, and then it's deleting some metadata here. In this case, this is nothing related to my Lambda function or anything that I'm working with. So we're good. So what we'll do next is we'll deploy our code, and then we'll test it. So let's just run a CDK deploy. And I'm not passing in the require approval never flag, because I actually want it to ask me if I want to deploy these changes. So you can see it's telling me that there's a new IAM statement that's being created, and there's a new policy. So these are the IAM statement changes and policies, and this is for my Lambda function. So it's saying that Lambda can assume the role that it's creating with this service role here. So we created this assume role policy and this manage policy arm that we're attaching to the Lambda function service role. So we will say yes, and then we will let it deploy. And while that happens, I'm going to go to my account over here, and then we'll bring it over here. Perfect. Okay, so we will wait for that to deploy. We're in Virginia, so we'll go to our functions here, and then give that a moment to deploy. And then we'll test it out, and we'll see. But what you see here is the CDK. If you look at this output here, it's bundling my application code. It's pushing that code to S3. And when it pushes that code, it is pushing it to that asset bucket. So when we bootstrapped our account, we talked about this in the last episode of the workshop. When you bootstrap that account, it creates an S3 bucket where we store assets and anything that we need to reference across our CDK applications. So it pushed those assets to that bucket, and then now that Lambda function is pointing to this particular asset in that bucket. So it bundled it, pushed it up there, and connected everything together. So now if we refresh, we should have our function deployed, and we do. And we'll go back to the workshop and follow along, and we'll hit the test button. Okay, so we could pass an event if we wanted to, and we'll use this one right here. Actually, we'll use the API Gateway AWS Proxy Test event. So let's go down here, and then again, you can see here's my code. Super cool. We're going to hit test, and then we will look at a template here. And then do we have the proxy one? Let's take a look. Perfect. So we'll use that proxy. So again, remember, as I mentioned earlier, that every time when a function is invoked by another AWS service, it gets that event input, and that event will contain the details related to whatever it was that initialized that Lambda function, that called it. So in this case, it's an API gateway. It's an API gateway proxy event. That's the request is being proxied from API gateway to our Lambda function. So this is what an example event would look like. So we'll just name it test, and then we will click save, and then let's test. Let's run the test. Perfect. So there you go. You can see the test event ran. We got our response, which is that hello CDK. So if we go back to here, you can see hello CDK, you've hit event.path. And you can see here's the path to resource. And again, going back to our test event, you can see path to resource. So we could say path to CDK land invoke, and then again, we're good. Did I put the, oh, I didn't save it. Okay, perfect. So we've deployed our Lambda function. We tested it, everything's working. The CDK bundled our code for us. Now let's move on to the next step. So one thing, when we're talking about CDK and we're talking about bundling your application with your CDK code, a big question comes with regards to testing and testing your changes and seeing those changes in real time, not necessarily locally, but seeing them running in a real world environment and walking through those. So this is where two things are super helpful with the CDK CLI. One of those is the CDK watch command, and the other is hot swap deployments. So if we were to run a CDK deploy on our own, you can see, by the way, fun fact here, at the time this workshop was created, we had, let's see, it took 72 seconds to deploy. Let's make a change and just run a CDK deploy, CDK live workshop. So we changed it to CDK live workshop, and then let's run a CDK deploy. So if you had to do this every time you made a change to your code, it'd be a little bit painful. So instead of having to run a CDK deploy every time you make a change, this is where hot swap deployments and CDK watch come into play. So with CDK watch, it will essentially watch it will monitor any changes made to your CDK code or to your application code. And if any changes are made, it will deploy those automatically, and it will deploy them using hot swap deployments, which we'll talk about in just a moment. So you can see it took 28 seconds to run that deployment. Now, I just wanted to point out, it took 72 seconds back when this was created in the workshop. It's been probably some time since this particular portion of the workshop was updated. And this just speaks to the performance improvements that we saw on the CloudFormation side. CloudFormation's constantly improving and working on speed and optimizations on the back end. So pretty cool to see that, just in that period of time, how much faster a deployment is. So, okay, let's talk hot swap deployments. And again, hopefully everyone can see and everything looks okay on the screen here. So to speed this up, so you don't have to wait the 28 seconds for a deployment, you can deploy using the hot swap flag. Now, what the hot swap flag does is instead of initiating a deployment through CloudFormation, it will just behind the scenes, or it'll go around CloudFormation, and the CDK will update that Lambda function. It'll update the code and then update the Lambda function using API calls. So one, this will speed up your deployments, but two, it does introduce drift in your environment. So when you deploy using hot swap, it's just recommended for this local testing to get changes out quickly. But again, it introduces that drift. So you do want to make sure that you run a normal CDK deploy, and then for afterwards, and then for production environments, you want to make sure that you're not using hot swap because again, it introduces drift. So you wouldn't want that in your pipelines or anything like that. So let's make another change and then let's deploy using the hot swap flag. So we'll say, again, I'm not going off the workshop here. This is where I kind of riff a little bit. It's easy. And we'll say, hello, CDK live workshop, and we'll say hot swap. And again, if we were to go back to our code here, you can see, oops, where did I go? Let's go back to our function. And then we have our latest code, which was that hello CDK live workshop. So now what we're going to do is we're going to run a CDK deploy, and we're going to pass -- hot swap. So CDK deploy -- hot swap. And what we should see is a performance improvement here, and pretty drastic one at that. And again, because what's happening is it's hot swapping the resources, not using CloudFormation. There's no state management. In this case, it's ignoring CloudFormation as the state management and just directly deploying to via the APIs to AWS Lambda. So that was 6 seconds. It deployed it. And then if we go back to my function here, so again, we now have introduced drift into our environment. But on the next code change, that would then bring, and if I ran a normal CDK deploy, it would bring, it would remediate that drift. So you can see here, hot swap. So it deployed that change, and it took 6 seconds. So I saved myself 23 seconds without having to have CloudFormation in there. And this is good for local testing. Now, I probably don't want to run CDK deploy every single time I'm making a change. So this is where the CDK watch command comes into play. So first thing I want to do, though, is I want to modify my CDK JSON. Let me make sure here, because we don't want to exclude, let's see, exclude. So it's watching for, so it looks similar to this. So we have to remove, let's see here, from the exclude. So we want to remove this right here, this.js. So from the exclude list. And so what this will do now is anytime CDK watch is looking for any changes, if I make changes to my application code, because I'm using JavaScript for my Lambda function, it will catch that change and then trigger deployment. So let's do this, close that, and then bring this back up here. And now we're going to run CDK watch. Okay, so you can see here's all the directories CDK watch is observing. So you see it's observing my my Lambda function code for any changes, and these are all the directories and all the code files that it's looking at. Okay, so now let's make a change to our code here. So instead, we're going to remove all this, and we're just going to say CDK watch. And oops, I saved it. And now what's happening is it's catching that change, bundling the asset, pushing to S3, doing a hot swap deployment. And if I go here and now we refresh, what we should see is our new code. So CDK watch. So again, as I'm iterating on this code, making changes, CDK watch is going to catch them and then deploy them. And again, it's using the hot swap here for faster deployments, but I could always run CDK watch with a flag that says no hot swap, and then it will do normal CloudFormation deployments of that Lambda function and all its resources. Okay, so let's go back to the workshop here, and we've done a couple really cool things here that we should highlight. Number one, we defined our Lambda function and we deployed it using the CDK. We bundled our application code assets directly in our application, in our repo here, where our CDK code lives. The CDK is able to bundle those assets, push them to S3, and then connect them to that particular Lambda function that we're deploying. Not only did we do that, we then took it a step further and wanted to, iterate faster, see how we could actually test these changes at a bit of a faster pace. So this is where we introduced hot swap with our CDK deploy, where we went around CloudFormation just for our Lambda code and saw that we could get a faster deployment when we did the hot swap. And then we used CDK watch so we could just run, iterate on our code, make our changes, and then CDK watch is going to monitor any changes to our application code or our CDK code, and then automatically deploy those changes. So again, pretty cool. So now let's move on to putting an API gateway in front of our Lambda function. So at this point, we have a function, it works, we've tested it, but now we want to actually take this function and put it behind a REST API so it can serve traffic and actually respond to requests. So we're going to use the Lambda proxy integration with API Gateway. So API Gateway has a lot of really cool integrations where basically we can just, API Gateway smart enough to connect to AWS Lambda on a request that comes to a particular path, it will route that directly to that particular Lambda function. So I am going to go back to our CDK code here, and I'm going to import API Gateway as API Gateway from this. Perfect. And I do have hot swap still running. I'm probably going to actually just turn off hot swap at this point. Okay. So let's pass in. So we'll create a new API Gateway dot Lambda REST API. And again, if we go back here, API Gateway. Oh, actually, are we using the V1? Oh, we're using the V1. We should use the V2. Oh, V2 is actually, so there's a V2 and a V1 for API Gateway. If you're using REST APIs, API Gateway, the V1 is going to be good. If you're using HTTP APIs with API Gateway, the V2 is going to be your friend. So let's go back here, and then you can see we have our Lambda REST API. But if I go to the overview here, again, great examples, things that I can work with to get started, various use cases. So you can see like mutual TLS here, MTLS, custom domains, logging, API keys and usage plans. I can read up on these particular features and functionalities of this particular construct here within the API docs. But in this case, we're going to go very simple, but we're going to use the Lambda REST API. So I did talk about in the previous session about the levels of constructs. If you're interested in learning more about the various levels of abstraction within the CDK, which when you talk to folks that are using the CDK, folks in the community, myself, the one thing you'll hear most commonly is that one of the biggest value propositions of using the CDK is leveraging the abstractions. And that's these L2 and L3 constructs where a lot of the kind of the boilerplate connecting of backend resources, defaults, and all these really great things are built into those L2 plus constructs. So we have a video on that in CDK Live, CDK.live website, YouTube channel. Check it out. But this is where I can read more on this particular API. But what I want to do here is I'm going to use the Lambda REST API construct. So this construct is going to automatically connect the API gateway to the Lambda function. It's going to set up that integration. I don't have to worry about setting all of that up. I'm just going to call this particular construct and pass it in here. So we're going to say this is our, we'll say API gateway endpoint. And then we'll look at our properties here. So in this case, our handler is going to be hello, which is our Lambda function. So we've defined our Lambda function. We're creating a REST API, and this REST API is using the Lambda proxy integration. So all requests that come in will proxy to this Lambda function. And then you can see here's all the other defaults, or all of the other properties that are available to me when I'm creating this API gateway. But again, we're going very simple here. I could name it if I wanted to, but I'm just going to leave it as is. And now let's run a CDK diff. Let's see what's changed. CDK diff. And what we'll see is that the CDK, again, is going to trigger a change set API call to CloudFormation. And we're going to look at what has changed between our current state and our desired state, which is defined in our code right now. So you can see here the IAM policies that are being created, all of the REST API, the deployments, the permissions, the methods. So I believe we're just going to actually go. This is going to proxy anything that comes into root, the root of the API, to the Lambda function. But again, when I talk about these abstractions, you look here and I just define this. Now, granted, I want to say that generally folks go beyond the defaults. You get to a point where the defaults are a great starter, but obviously you build on these, and there, you'll add more lines of code as you build to make it work for your use case. But just with these 3 lines of code, I was able, and really, this is just my this is just my my formatter. I use Prettier, but really it's just 1 line of code. See how I did that? And with that 1 line of code, it is creating all of these resources for me, because it's an opinionated construct that knows that's scoped to a REST API with the Lambda proxy integration. I pass in the Lambda function that we want to proxy to. It handles all of the IAM policies, the assume roles, what principal can assume what role to talk to what resource, and creates all of this on my behalf. So when you think about that, if you were to author this on your own, that is, it's a pretty substantial amount of effort that's being handled on your behalf here. So let's run a CDK deploy, and I'm going to pass in the require approval never flag. And that just, what that does is it won't prompt me to approve when it's making changes to IAM or any security group changes. So you will typically be prompted for an approval if it's anything that's security related, a security related change to your CDK application. So IAM roles, security groups, anything that would be deemed security in that sense. So we're going to let the deployment happen. In just a moment, it's going to output, because as a part of this construct here, it actually builds a CloudFormation output, and that output is the endpoint for this API gateway. So we could hit this endpoint now, and if I were to go here in my browser and hit it, you can see I'm here. So test CDK live. And there's our code working. Again, it still has that CDK watch. But you can see it's returning that data. We've deployed our API gateway, public facing in this example. And we did all of this with just a few lines of code. So again, when you really think of the power of the CDK, I'm able to define all of my infrastructure as code using a general programming language. So I like TypeScript here, but you can also use Python, JavaScript, Go, C#, Java, and I'm able to make programmatic decisions. I can, take advantage of control flows or control loops. I can have conditional statements, and I can do it all using the native programming language that I'm familiar with. And that's, by the way, not to say that other infrastructure as code languages don't have that functionality. They do. But if you prefer to just stay in the language that you like to author in, the CDK is just fantastic for that use case. On top of that, I get to leverage these abstractions, these L2, L3 constructs that handle a lot of the defaults and a lot of the boilerplate. So I don't have to define hundreds of lines of infrastructure code just to solve the use case that I'm looking to solve. So in this case, I am using the Lambda REST API construct, which handled all of that, the authoring of all of the underlying infrastructure as code templates to make sure that my Lambda function can actually handle that call and receive it and then respond. And I didn't have to define the IAM policies or do any of that, any of the boilerplate to connect everything together. Now, all that said, you still have the ability with the CDK, if you want to go lower and define things at the lower level resource, you absolutely can. So you have a lot of flexibility when you choose how you build your resources in the CDK. But just know that there are some cases where if you're leveraging a higher level construct, like a level 3, which is like a pattern, think like an application load balanced Fargate service pattern. Sometimes when you want to break beyond like what that opinionated pattern offers, it can be more challenging. So that's where certain use cases, it may make more sense to just build those resources using the lower constructs to get your desired state. Okay, so that's it for today's section of the workshop. And again, just to do a quick recap, we cleaned up our code that we deployed in the first section of the workshop. We defined our application code. So we built this hello.js, which returns the path of what the user hits in the browser or in the API endpoint. And we built that function using Node.js. We then, in our CDK application, we defined our Lambda function. We pointed it to the directory where that code lives, and the CDK built that Lambda code. So it actually built that asset. It bundled it, I should say. It bundled it into a zip file, pushed that to S3, and then connected that Lambda function to that code. And then we put that Lambda function behind an API gateway. And we were able to leverage a higher level construct, the Lambda REST API construct, which again handled all of the connecting of all the resources together to make sure that that integration worked as we needed and as we expected. And then we were able to also walk through local testing with serverless functions. We looked at the hot swap functionality where the CDK will, instead of deploying through CloudFormation to get faster code deployments, it'll just call the APIs and deploy that function code going around CloudFormation. So for local testing, we also use the CDK watch command. So CDK watch monitored our CDK application as well as our application code for our Lambda function for any changes, and then automatically deployed them anytime we made changes to those resources. So one other thing I want to add is if you're working with containers and Amazon ECS, the hot swap functionality does work there as well. So if you want to just go through faster container deployments, you can also use this functionality with ECS as well, ECS services. So that's it for today. In the next workshop, the next section of the workshop next week, what we're going to walk through is creating our own constructs. So we've done everything now in a CDK application. We've kind of built our stack of our static resources here. What we'll look at next week is how do we make a more generic reusable module or construct, and then leverage that construct in our stack when we're building resources. So that's going to be for next week. And then in the meantime, if you have any questions or you're just want to chat, please feel free to reach out on Twitter at RealAdamJKeller, or you can always post a comment on the video. Glad to respond and chat with y'all there. But thank you so much. And in the meantime, we will catch you next week for part 3 of the workshop series. So thank you so much.